By using the given area, show that the angle theta satisfies the equation 162 theta minus 162 sine theta minus 308 equals 0. By using the given area shown. Let's take a look at the diagram in question and see what areas they are showing us. The circle of area pi r squared or pi 18 squared. The segment, the sector, and the triangle cast by the side of the segment. Just by looking at them, you can see that segment equals sector minus triangle, which is even easier to see if we split them apart. Now the area of the segment equals 308, which is given. The area of the sector is the portion of the entire circle carved out by the angle theta, or theta over 2 pi, times the whole area of the circle. Theta over 2 pi times pi 18 squared, 18 being the given radius. You can already see the beginning of the answer. The area rule of a triangle is that in any triangle ABC, the area of said triangle is equal to half BC sine A. In our specific case, that means that the area of the triangle is equal to a half times 18 times 18 times sine theta. Put it together and you see that 308 is equal to theta over 2 pi times 18 squared minus a half times 18 times 18 times sine theta. Pi cancels out. 308 equals a half 18 squared times angle theta minus a half 18 squared sine theta. 18 squared over 2 equals 162, so 308 equals 162 theta minus 162 sine theta, which is equivalent to 162 theta minus 162 sine theta minus 308 equals 0. Question 5.2. Use the Newton-Rhapson iteration to determine theta in radians to 5 decimal places using an initial approximation of 2 radians. You must state the iterative formula that you have used to produce your answer. Let's quickly recap the Newton-Rhapson method. Given a function f of x, find a root r such that f of r is equal to 0. The Newton-Rhapson method approximates the roots of a function. We start out with an approximation x of n. Then we make the approximation of the derivative of the function f of x as a linear function. We get f derivative of x is equal to the slope of the linear function, which is equal to f of x over x of n minus x of n plus 1. Rearrange that and you get x of n minus x of n plus 1 equals f of x over f derivative of x. X of n plus 1 is equal to x of n minus f of x over f derivative of x. Let's take this to our problem. Define the function of theta as in 5.1. F of theta equals 162 theta minus 162 sine theta minus 308. The initial approximation of x of n is equal to 2. X of n plus 1 is equal to x of n minus f of x over f derivative of x. Therefore x1 is equal to 2 minus 162 times 2 minus 162 sine 2 minus 308 over 162 minus 162 cos 2, which gives you 2,57235 and so on. x2 is equal to 2,500,635 and so on. x3 is equal to 2,499,837 and so on. x4 is equal to 2,499,837 and so on. By the fourth iteration, the change is less than 5 decimal places, so rounding up, we get that theta is equal to 2,49984.